think this is tremendously useful to me, and I think it will be to you. All right. So create, check. If it's not exist, then create. If it exists, quietly skip over. Then in the drop case, it's the other way around. Drop the table if the customer table has been successfully created, but otherwise quietly move over, right? So always insert them. Now, this part is what we were talking about in terms of the schema, which is a piece of text that describes in what order, with what name, and with what data type each column has. Okay, so there is a sort of totally airtight description of the behavior of each column. As for rows, basically that's up to the insert and delete to operate. So creation of schema is very much column oriented. Schema describes how many columns, what column names, what data types, and so on, and other properties like is this primary key? Primary key basically is a necessity even though it is not programmatically checked. So if you don't have a primary key, all right, you can successfully create it. It will allow, but then it's not a good design. It's not a good behavior. So all tables should have a primary key. That's something you keep in mind. And it's very simple, very lightweight, because all it needs is a unique integer. So you define a data type integer and keep on having 0, 1, 2, 3, 4, 5, and each new row is added is a new number. That's all. It's always unique. A primary key says that the columns value, the future to be added data, they are always unique. They don't duplicate previously held data. They will never be reused. So if you insert a row 0, 1, 2, and you delete 1, so there's a gap there, right? So it becomes 0, 2, isn't it? If you insert one more new row, what happens to the primary key? It's not going to reuse the 1, but it's going to be 3. That's right. So that behavior is a little bit like our national ID card, right? Yeah, so someone who is sort of being born, you will get a new ID, and when someone passes away, that ID is never reused. Okay, for longevity of data uh, uniqueness. So we do not reuse primary keys. We do not. Okay. And also that goes for passport. If a passport is found invalidated, that passport number is never reused. So all these are primary keys. They are primary keys, and their creation may not be from us. However, we can use them so long as they are ensured to be enforced to be unique across the entire database and across time. So it's pretty stringent in terms of the behavior, overall behavior, not single data behavior, but overall behavior of the entire column of primary key values. So primary keys are definitely unique, but unique columns need not always be primary keys. So what are unique column values? Unique column values can be choice of food. Also, what are the burgers being sold in this restaurant? So we create a table of choices. So the choices can be beef burger, chicken burger, rice burger, let's say, just 3 types. So they are unique, right? Yeah. And but they are not necessarily sort of unique across the whole country, because another branch will also be having these 3. So they are locally unique and sufficient for this purpose. So it can be unique, but not suitable, right? Let's say not suitable for use as primary key. Furthermore, the column values are unique: beef, chicken, and rice. However, when we move over to the transaction, this person bought 3 beef burgers, that person bought 5 rice burgers, right? Next day, 2 beef burgers, 6 rice burgers, and so on. So they are being used again and again, and basically they refer to the different instances of the beef burger, and this beef, rice, and chicken basically describes the unique types of burgers, but not individual burgers. Yeah, so I'm just trying to illustrate that there are cases when we have unique data, but they are not really suitable for use as primary key. But if you have to use it as primary key, it will definitely be unique in the first place and across database, across time in that sense. Okay, SQLite data types, since we are talking about schema, basically internally, just one quick word about how SQLite understands all these descriptions. Yeah, you could see SQLite databases having um, descriptions like I want ID to be of integer type, but sometimes you will see ID to be numeric type. What's the difference and all that? So these are data types that SQLite understands, and also we understand, but we are not assured of integer being of exactly what kind of storage format internally. All right, for example, name is a text, okay? Address is a text, but is name storing, is the column of name 50 character long, 100 characters long, 250 characters long? We don't know. It's up to SQLite to maintain flexibly for us. Yeah, and we also have real, right? Salary here as real. Real simply means like Python's float. That means there will be decimal places. Again, this is really up to SQLite to implement. Maybe it detects that you are using a lot of high, that means long decimal place numbers, then internally it is probably going to use even higher precision, uh, that means taking up more memory kind of storage to represent your large decimal real numbers. So all these handling are done by SQLite. And I'm trying to say that it's not always clear, all right, in a good way, so data will be converted appropriately. So it's not always clear real means what, numeric means integer, or is it floating point? We're not always sure, but by and large we can think of the equivalent translation. Integer means int, real means float, numeric means float, text means string, block means bytes, right? So basically the uninterpreted 8-bit storage units. So table on the right shows this, and it's just for quick understanding, by no means asking you to memorize them nor fully interpret it. Oh, next time when I have integer, I'm trying to imagine. Because remember, SQLite can work on its own via SQLite Studio or other programmatic access. It doesn't have to be Python. Remember that. It can be via C, C++, or other mechanisms. So here, this is just for kind of understanding, since you are already kind of already quite familiar with Python data types by now when you watch this. So I'm just giving you some sense of what is this integer thing? How do I think about it in terms of Python? So do have this in mind just for the sake of a more gradual learning curve to understand SQLite's data type. So don't try to memorize it or to enforce this equivalence translation of the types. Okay. See you in the next video.